In this lesson, we learn about depth of field. Depth of field basically is the range of acceptable sharpness within a photo that will appear in focus, or in simpler terms, the parts of the image that are in focus. If the areas of focus are very small in the image, we have a shallow or a narrow depth of field. You can see in this image in which the camera's target is on the clock, only the clock is in focus, and as we get closer from the clock to the camera or from the clock to what's behind it, the image gets more and more out of focus. And this gradual change from focus to out of focus areas happens very fast. Here we say we have a shallow or a narrow depth of field. On the other hand, like our next render, if the areas of focus are very large in the image, we have a wide or a deep depth of field. In this image, you can clearly see a larger area is in focus compared to our previous render. Now let's see where we can enable depth of field in the Corona camera and what factors control the depth of field in your render. Select the Corona camera tag. And as you can see from the top view, the camera's focus distance or target or focal plane is on the clock. In order to enable depth of field, you need to come down to the DOF section and enable depth of field. If disabled, the entire scene will be sharp and in focus, so let's enable it for now. Right now we are using a simple exposure value, so changing the f-stop wouldn't affect the exposure. The deciding factor on how narrow or wide the depth of field is the aperture size, which is being controlled by the f-stop number. In the first lesson of this section, we learned that smaller f numbers mean larger aperture size and larger f number means smaller aperture size. Now we need to add another concept here. The smaller the f number means larger aperture size and also narrower depth of field. And on the other hand, larger f number means smaller aperture size and wider depth of field. Just to simplify this again, the smaller and lower your f number, the narrower or shallower the depth of field, and the larger and higher your f number, the wider or deeper the depth of field. Now let's run the interactive render and try a few different f numbers or f stops. Let's set the f number to 1.4. We have a very shallow depth of field. Now set the f-stop to 2. Still very shallow, but a bit wider depth of field compared to our previous render. Let's try 4. Still shallow, but again a bit wider. Now let's try 8. And finally 16. When set to 16, you can see we have quite a wide depth of field and most of the scene is in focus. So again, the smaller and lower your f number, the narrower or shallower the depth of field, and the larger and higher your f number, the wider or deeper the depth of field. For now, let's set the f number to 2. The next thing you probably want to know is how to change the focus distance. Right now, the target or the focal plane is on the clock. If I want to make sure the box and the bottle are in focus, all I have to do is to make sure the focal plane is on the box. So let's do that in the top view and increase the focus distance to around 135 centimeters. And now as you can see in the render, the box and the bottle are in focus and the clock becomes out of focus. If you select Cinema 4D camera itself and go to the Object tab, we can simply use this Focus Object field and pick any object that we want to be in focus. So let's pick this clock to be our focus object again. Another factor in how narrow or wide the depth of field is going to be focal length. And the rule here is the longer the focal length, the shallower the depth of field and vice versa. It's not as important as the f number, but it contributes. But the more important factor after the f-stop in depth of field is the scene scale. Basically, the smaller your scene and your objects, the shallower depth of field, and vice versa. Let's see how that works. For now, I'm gonna set the f-stop to around 4, and I'm gonna render the scene for a minute. Now stop the render and store the current render. This is the depth of field that we get with the current scene scale. Now from the edit menu, if I open up scale project and set the current scale to 10 and target scale to 1, essentially making the scene 10 times smaller, and press OK and render the scene for another minute. Now, even though we have the exact f-stop value of 4 for both renders, but we get much shallower depth of field in the second render, in which we had a 10 times smaller scene. I'm going to stop the render again, and from the scale project option, change the scene scale to its original scale by turning 1 into 10. To be able to understand the rest of the depth of field options in the Corona camera a bit better, I have a second cinema 4D sky with a different HDRI assigned to, so hide sky 01 and unhide sky 02 and run the interactive render. I'm gonna set the exposure to about 1 and highlight compression to 1 as well, and set the f-stop to 2. Now let's talk about bokeh. Bokeh, if technically defined, is the quality of out of focus or blurry parts of the image, or simply the pattern exhibited in areas of the image that are out of focus. First, we have aperture shape, whether circular or bladed. When parts of a photo are very much out of focus, the blurred highlights in the photo tend to take on the shape of the lens aperture. Right now the aperture shape is set to circular, so the out of focus highlights will have a circular shape. Let me just draw a region around these highlights in the background. Now if I select bladed and set the blades to 3, we're going to have a triangular aperture, which results in a triangular out of focus highlights. Instead of using only circular or bladed types, you can set it to custom and define your own bokeh pattern. If you want to get the same result as the circular type by using the custom texture mode, for example, we would have used a white circle that fills a black background. So you can create your own shape on a black background and use it here as a bokeh texture. Now let's try a few aperture shapes. If set to circular, we get circular out of focus highlights. And if set to bladed and blades number, let's say set to 3, we get this triangular out of focus highlights. Set it to 4 and we have rectangular out of focus highlights. Let's try 5. And we get this pentagon shaped highlights. For now, let's set the blade counts to 3. And we have this rotation value, which allows us to rotate the aperture and therefore rotate the out of focus highlights. Let's try 25 degrees. And as you can see, we have rotated the out of focus highlights. Set the shape to circular for now. Next, we have center bias. This parameter biases the transparency of the aperture towards the center with negative values or the edge with positive values. Positive values like 2 or 5, which is the maximum amount, increase the amount of blurring in out of focus areas and create this beautiful ring effects in the highlights, while negative values like -2 or -5 decreases the blur and makes the depth of field to be quite wider. I'm going to set the center bias to 0 for now. Next, we have vignetting, and this parameter vignettes the frame by simulating the cat's eye effect that some wide angle lenses can generate. I'm going to close the region and restart the render. Let's try 0, 1, 2, and 3. Negative values for optical vignetting would produce the same result as positive values. I'm going to set it to 0 for now. Next, we have an isotropy or anamorphic lens value. Here you can simulate an anamorphic lens by stretching the aperture vertically with negative values or horizontally with positive values and therefore stretch your out of focus highlights. Let's set it to set the anisotropy to negative 0.8. The effect is a bit exaggerated here, but you can use smaller values to get more realistic anamorphic effect. As you can see, the bokeh is vertically stretched. Let's try 0.85, which stretches the highlights in a horizontal direction. Set the anisotropy to 0 for now. We can also produce depth of field as a post effect using the Z depth render pass, but we will discuss that in its specific lesson later on in the course. And for the final render, let's hide the second sky and unhide the first one. Run the interactive renderer again. Set the exposure back to negative 0.5 and highlight compression back to 1.5. In the render settings window, let's make sure denoising is enabled and set the render limit to around 64 passes. And finally increase the resolution to 1600s by 1600s. Now let me stop the render and show you the final render. As you can see, we get this beautiful shallow depth of field. So that's about depth of field in Corona. See you in the next lesson.